Use algebra to solve each equation. We have a problem in A. Do you see the question has a sine x and it has a cosecant x? Generally, you can't solve unless you're just dealing with the same thing. We've seen this a little bit before. Remember the ones with the hint where it said use sine squared plus cos squared equals 1? We had to use sort of a system of equations. Here we're going to do sort of something similar and just say, well, what could I change the cosecant to?
1 over sine.
I could change it to 1 over sine. And now, at least my equation only has sine. So now I can use all my algebra skills that I've learned up till now, and this one involves quite a bit. The first algebra skill you have to do is you have to multiply this 2 times that 1 over sine. And it seems straightforward, but I will give you 2 possibilities, and you tell me which one does your gut tell you to do. Does your gut tell you that 2 times 1 over sine is 2 over 2 sine, or does your gut tell you that it is just 2 over sine? Green. Right? This 2 is technically 2 over 1, right? How do you multiply fractions? You multiply the tops, you multiply the bottoms, so it is the green one. If you thought of the blue one, you're mixing up an idea of distribution and multiplying fractions. This is not a place where you distribute the 2 to both the top and the bottom, because then you'd be multiplying by 2 over 2, which is not 2. Well, that one is not right. And now, we have to go back to grade 11, because if these were just x's, you would have a rational equation where you have an x in the denominator. Do you remember how you solved rational equations? Okay?
What's that?
We got rid of them. That was the basic strategy. I don't like sine x on the bottom. How could I possibly not have sine x on the bottom? Multiply by a sine x. So if I take this whole side, and I multiply this side by sine x, well then I would have to take this whole side and multiply it by sine x. What would I get? Well, I would get 2 sine squared x here, and this is where we would distribute to each of those terms 3 sine x, and when I multiply here, sine x would cancel out, and I just get a 2. Yes?
I thought would be 3 sine x on the left side.
Again, if you have 2x times x
Yeah.
compared to 2x plus x, this will be 3 x's, because you're adding them.
Yeah.
This is the same as 2 times x times x.
Yeah.
The 2 does not change to a 3, because nothing's changing that 2 to make it a 3. But the x times the x becomes an x squared. So when I do sine x times 2 times sine x, the sine x times the sine x is sine squared. I still just have a 2 out in front. Okay? Here's this. Now what kind of question do we have? Another question from grade 11. A quadratic. How do we solve quadratic equations? Either by factoring or with the quadratic formula. But you need to make one side equal to 0. And you can either use your formula or you can factor. If you can factor, and if you can factor well, it is much faster than the quadratic formula. If you can't factor, or you can't factor well, the quadratic formula for you might be faster than factor. Okay? Now, because it's 2 sine squared x, your start off for factoring is really easy. The only possibility is 2 sine x and sine x. And the last number being a 2 gives you two possibilities. Like it's only 1 and 2, but 1 and 2 and 2 and 1 are going to be different in this situation. Because if I put the 2 here, which is right, can you see that it will hit here and make 4 sine x? And if I put the 1 here, this makes 1 sine x. I want to get minus 3 of them. So I think, well, sure, it would be nice to start off with minus 4 of them and just add 1 of them. Do a quick check. Does my last one still work? Right? Does 1 times minus? Yes, gives me minus 2. We already know that the first ones we wrote down, they work. And now we can split up our equation and say sine x can equal negative 1/2, and sine x can equal 2. Negative 1/2 is on your pi plate. It's your pi over 6 family. Negative in quadrant 3 and quadrant 4. And 2 is not on your pi plate, but still can be done without a calculator. For sine and cosine, if you get a number bigger than 1, it's impossible. You can't have hypotenuse be less than the sine. And if you think of this as a fraction, 2 over 1, and try to draw a right triangle where the opposite side is 2 and the hypotenuse is 1, that's going to be a problem. Okay?
Mr. Peck, please buzz your location. Mr. Peck, please buzz your location.
Now that I've solved between 0 and 2 pi, I should go back and cross, oh my goodness, what did they want? Yes! The domain is 0 to 2 pi. I don't have to make new numbers. Yay. Question?
Yeah, question.
Mhm.
How did you went from the factored version to the minus 1.5 and 2?
Okay, so when we factor, the reason we're factoring is because we want to change it to multiplication. And because we have it equal 0, this is why the 0 is so important. The only way I can multiply two things and get 0, one of them has to be 0. So here, if sine x is negative 1/2, that makes this one 0.
Mm-hmm.
And if it's 2 minus 2, that makes this one 0. That's how I find out what would make these each 0 respectively. Okay? So in this example, this is very typical. If you can do this, where you change things to sine and cosine and everything is sine or everything is cosine, life is easy again. Because then we just have to use all of our skills. This is tough though, because it uses all of your skills from like last year. First of all, we're using a new skill, changing it to sine. Then it's a rational equation. So you had to know how to solve rational equations. Then it was a quadratic equation. So you have to know how to solve quadratic equations. And then it became a pi plate question. So you have to know everything intertwines in math and is connected. Okay, so question number 2, or part B. Sine x equals cos x. I'm going to show you 2 ways to do this one. And I'm also going to show you the number 1 mistake that students do in this. Okay? First of all, the mistake is based on good intentions. The good intentions are, it would sure be nice if it was only sine or only cosine. Right? Because then you could solve it. It's a problem right now that we have a sine and a cosine. So students go and say, well, I know that the big idea that sine squared is 1 minus cos squared. So am I allowed to just say this? Can I do this? Please? Please? No! You can't. It is not allowed. That scare anyone? Kind of scared me a little bit. Okay? Oh, so just as far as scaring things are, very enjoyable. So pie plate judging was today, and Teddy's needs to be plugged in. So I just left it near the plug, but not plugged in. So when teachers were judging, they're like, oh yeah, and that one you just have to plug in. And so they would lean over, plug in, and it's really loud, and there's sparks, and it's terribly funny watching teachers jump and get scared. So, thank you. That was very enjoyable. Yes.
Can we see if we've got this?
Sure, here. There's a plug in the back there. Go ahead.
Can it kill?
Plug right there.
Because it's guarding
Yep. Just go over there and plug it in, Olivia. Yeah, you do it.
Is it scary? Like, what, is it
It's
actually
loud.
scary?
It's loud. It won't shock you. That's what you're worried about. As long as you're listening. In theory.
There we go.
Comedic moment.
Can you touch it? I wanted to. In theory, you can. I wouldn't try it.
In theory.
But-
In theory, yeah.
So is
Alright,
everything
there
in
you go.
theory?
Sounds like a
Oh,
yeah, you did say that you were gonna make
It's sparkly and very sci-fi.
Yeah.
You survived. That's very fun. Okay, so. Sorry. No, you can't do that. Isn't it tempting though? Can you do, it's like, I just square rooted both sides. Why is that not allowed? Again, sometimes when we check things with numbers, for example, 5 squared minus 4 squared happens to be 3 squared. Check it out, this is 25, this is 16, 25 minus 16 is 9. This is a true statement. Watch what happens if I square root both sides. Right? It's obvious this is bad here, right? But sometimes it's not obvious that it's bad there. And our brain goes, oh, good idea, I should do this. No, bad idea. Okay? But that's number one mistake. If you're tempted that sine squared x is 1 minus cos squared x, which is a big idea, it's always true. You can't just square root both sides. In fact, we can only use the big idea if they're squared. And today we're also going to learn the other 2 squared ones that go with it. So, there's the main way to go wrong. So now I'm officially stuck on this question. Method 1 for this question. Use your pie plate. Is your x coordinate ever the same as your y coordinate? When? Pi over 4. Anywhere else? 5 pi over 4. They're both negative, right? Perfect. That's method 1. Just use your pi. There is a way to do this one with identities. Okay? If I take that equation and I divide both sides by cos, which is a little bit dangerous, because sometimes when you divide by sine or divide by cos, you might be dividing by 0 without knowing it. But in this case, if cos is 0, is sine 0 at the same time? No. So technically that's not a solution, so you are allowed to divide by cos. And if I divide by cos, what could I change sine over cos to? I could change it to 10. And then you're like, hey, wait a minute, is that on your pi plate? That's my pi over 4 family. In quadrants, 1 and 3. Same answer. I should do that sometime. I should say method 1 and you get 1 set answer. Then do method 2 and the answers are totally different. And this is method 3, new, completely different answers every single time, and you're like, what happened? But no, they should be the same answers if you use 2 different methods. Okay, so this also here is using an identity to help you solve it. You can circle question number 10.